6-5 covers finding real roots of polynomial equations. In Lesson 6.4, you use several methods for factoring polynomials. As with some quadratic equations, factoring a polynomial equation is one way to find its real roots. Recall the zero product property from Lesson 5.3. You can find the roots or solutions of the polynomial equation p of x equals 0 by setting each factor equal to 0 and solving for x. Number 1 on Classwork 6-5 asks you to factor. Because the coefficient of x squared is only divisible by itself and 1, making it a prime number, we are going to use guess and check to factor this polynomial expression. So we have 2x and x are our only options. I'm looking for two numbers that multiply to 56, and then when you multiply one of them by 2 and the other by 1 and add them together, you get 23. Okay, 56 could be 1 times 56, 2 times 28, 7 times 8. Let's use 7 and 8. If I place a positive 8 here and a positive 7 here, 2 times 8 is 16. 16 plus 7 gives me 23. So my factors are 2x plus 7 and x plus 8 equal 0. If I set each of these factors equal to 0 and solve for x, that would give me my 0 or solution. So 2x plus 7 equals 0. Subtract 7 from each side. Gives me 2x equaling negative 7. Then divide each side by 2. So x equals negative 7 over 2. The other equation, x plus 8 equals 0. Subtract 8 from each side, and x equals a negative 8. So my two solutions are negative 7 over 2 and negative 8. For this one, 8 could be factored into 1 and 8 or 2 and 4. Because our coefficient on x squared has more than one set of factors, I'm going to use my father drives red Mustang. Okay? Those steps are my father drives red Mustang. Okay? The M is for multiply A and C. So in 8x squared minus 18x minus 81 equaling 0, this is my A value, this is my B value, and this is my C value. So when I multiply A and C, I get x squared. Notice when I multiply them, I drop the A value, minus 18A minus 648 equals 0. I'm then looking to factor. So I need two numbers that multiply to negative 648, but at the same time those two numbers add to negative 18. So my possibilities for negative 648 could be 2 times 324. I could do 3 times 216, 4 times 162, 6 times 108, 8 times 81, so on and so forth. I need bigger numbers, so I'm going to jump up, and I've got 18 and 36 are two options. Okay, I'm going to use a negative 36 and a positive 18 because I need, when I add them together, for them to equal negative 18. So negative 36 times 18 gives me negative 648. Negative 36 plus 18 gives me negative 18. Next step, I'm going to divide by my a value. So my a value in my original equation was 8. So I'm going to make each of these a fraction. So 36 divided by 8 and 18 divided by 8. Then I'm going to reduce the fraction as much as I can. So 36 over 8 can be reduced to 9 over 2 when I divide top and bottom by 4. 18 over 8 can be reduced to 9 over 4 if I divide top and bottom by 2. The last step is to move the denominator of my fraction in front of my x. So this now becomes the coefficient of x. So 2x minus 9 is one of my factors. The other is 4x plus 9. The last step is I set each of these factors equal to 0 and solve. So I have my factors 2x minus 9 and 4x plus 9 equaling 0. If I do 2x minus 9 equals 0, I add 9 to each side. 2x equals 9, so x equals 9 over 2. Do the same with 4x plus 9, so 4x plus 9 equaling 0 means that x equals negative 9 when I subtract 9 from each side, divided by 4. So my two solutions are 9 over 2 and negative 9 over 4.